I'm Victoria Morin.
And I'm Anish Patel.
I'm Desiree Romero.
And I'm Ashley Stone. And our project is 5S Lean Manufacturing Workstation Design in Silverline. The objective of our research was to optimize screen frame production at Silverline. This was accomplished by implementing 5S Lean Manufacturing. For background, we will define 5S and discuss Silverline and the company's products. We will then explain the current production methods, the problems we chose to target, and our proposed solutions. In closing, we will explain how our modifications benefit Silverline and their workers.
So the role that we had to play in this project was to be industrial engineers in manufacturing. So to provide a bit of background, industrial engineers figure out how to complete a task in the most efficient and best way possible. They do this through planning, design, statistical analysis, and problem solving. For us, one of our main goals is maximizing profits, efficiency, and minimizing wasted resources and worker injuries.
So background on Silverline. Silverline was established in 1947 by Arthur Silverman. It wasn't until June 2006 that Anderson Corporation purchased Silverline Corporation. Since 2006, Silverline has become the nation's leading vinyl window and door manufacturer because of their energy-efficient and low-maintenance products.
5S is an organization method used to maximize profitability and efficiency. The goal is to make the work process obvious and intuitive. The 5 S's stand for Japanese words that embody organization, cleanliness, and standardization. First, sort means to arrange objects in a visible way. Once the objects are sorted, they can be arranged and set in order by decluttering the workstation. To shine means to clean and inspect machinery. And finally, the process can be standardized by maintaining the best practices and sustained through discipline and training. Sometimes a sixth S is added, safety, because the overall philosophy of 5S takes safety concerns into account. In our research, we focused primarily on the first three components of 5S, along with safety. The final two components, standardize and sustain, are dependent upon Silverline's adoption of the workstation.
There were a few terms that were very important to the nature of this project. The first was BRIEF scores, which stands for Baseline Risk Identification of Ergonomic Factors. BRIEF scores are used to analyze how strenuous a task is by seeing how much twisting, bending, or straining is involved. For us, our goal was to minimize the BRIEF score and make the workstation as ergonomic as possible. The second term is takt time, which is the necessary rate of production needed to meet the demand of the customer. It also equals the selling rate for a company. The third term is cycle time, which is the actual recorded time needed to produce 1 unit of product. And a step is said to be value added if it is essential to production and if it caters to the customer's demands or specifications. A step is non-value added if production can occur without it and if it does not contribute to the value of the product. Muda or waste is a contributor to a non-value added activity, and there are 7 different types of muda in lean manufacturing. Some of them are overproduction, defects, unnecessary motion, and unnecessary transport. And lastly, the two-bin system is used to reduce the time spent refilling the bins, and it is a solution to problem shortages and supply replenishment.
So these are some body movements used in recording BRIEF scores. The ones we focused on most were extension of the arms 180 degrees, 45 degrees, twisting of the torso, twisting of the neck, bending of the knees, bending over, twisting of the wrists, and other movements such as those.
In order to gain first-hand insight into the production process, we visited Silverline. There, we were able to get a sense of how the operators were assembling the screen frames. Once we understood the process, we proceeded to collect various data points. First, we recorded the cycle time, which is how long it takes to complete one frame from start to finish. This was our baseline for improvement. Next, we observed the workers to see what parts of their bodies are under the most stress, whether it be arms, leg, back, neck, shoulders, or wrists. Ideally, the workers should only extend 25 centimeters in front of them, and work should never exceed 50 centimeters in distance from where the operator is standing. So while we were observing the workers, we kept questions in mind, such as, how far are the operators reaching? Does it fall within the acceptable range? And also, what is the frequency of the motion? We kept an eye out for repetitive twisting and bending. We then used these observations to calculate a BRIEF score. And lastly, we looked for inefficiencies and ways the process can be streamlined.
So this was the main focus of our project, the workstation currently being used at Silverline to assemble frames for screen frame windows. If you look closely, you'll notice several things. One being that there are pieces on the work surface, another being the position of the conveyor belt, and finally the fact that there's no cushioning on the front ledge of the table itself.
So this is an example of an assembled screen frame. The most common way of assembling the frame begins with operator 1, who stands to the right of the workstation in front of the conveyor belt. Operator 1 labels 2 width bars, one with a warning label and one with a barcode scan label. After labeling both width bars, operator 1 then inserts the corner brackets with the square pieces into the top width bar only. Sometimes a metal clip, shown in figure 4, is included depending on the model, but in this case it wasn't. After inserting the corner brackets, operator 1 then passes all 4 bars to operator 2, who inserts the corner brackets shown in figure 5 into the bottom width bar. After inserting all 4 corner brackets, the length bars are then attached on top of the bottom width bar, followed by the top width bar. This completes the frame. Once the frame is completely assembled, then operator 2 then places the assembled frame onto the rack beside them.
So after we completed our analysis of the workstation and the work process, we noticed there were several issues that could be improved. One issue was the fact that there were pieces on the work surface, as the clutter would limit the handoff of parts. Another issue was that when a worker ran out of parts, they would have to refill their parts, which would require them walking considerable distance and wasting time. Another issue was that with the position of the conveyor belt, it required one worker to work at the side of the table, which meant it was more difficult to hand off parts from the first worker to the second worker. Another issue was with the lack of cushioning on the front ledge. It meant that there was a risk for soft tissue compression, which is a factor of a brief score, meaning this job would be more strenuous. And finally, when we were observing the work process, we noticed that the step of applying labels was inefficient and it could be improved. So we came up with a couple solutions. To deal with the clutter issue, we decided to use a 2-bin system as it organized the parts and put them in easy reach of the corresponding worker. To deal with the refill issue, we decided to place extra bins underneath the table so that when the worker does need refills, all he or she has to do is just reach under the table. To deal with the conveyor belt issue, we decided to cut out a section of the table so that the table be slid into place with the conveyor belt and have both workers on the front edge of the table working side by side. We decided to add a cushioning so there was no risk of soft tissue compression while they're working. And to deal with the step of applying labels, we decided to purchase both a label dispenser and a label printer, which both were able to peel the stickers off from the paperback and thus use less time for that step itself. And here's how the table is currently at Serverline. It was still being constructed at the time, but at the moment there are 2-bin systems. There's a cutout section of for the conveyor belt, and there's the cushioning. The printer and the dispenser aren't shown, but they're currently being shipped over and implemented into our table.
So because our table is still being constructed, we couldn't put into practice, but we developed a set of theoretical results. First off, the refill frequency would be reduced from 3 refills per shift to only 1, and each shift is 8 hours. The total cost of constructing this workstation would be $922, but this would be paid back in about 1 month. The workers would be able to produce 870 more frames per week, and there would be much less risk of soft tissue compression.
As mentioned previously, brief scores were recorded before the workstation was changed and projected after the workstation was changed. Operator 1 had a brief score of 25, which is a medium job hazard score. Operator 2 had a brief score of 34, which is a high job hazard score. By adding cushioning to the top ledge of the workstation and the bottom ledge of the workstation, this limited the amount of soft tissue compression. By inserting the conveyor belt into the table and placing the bins in different spots depending on the workstation, depending on the workers, this limited the amount of reaching over. Also, the insertion of the conveyor belt into the table limited the amount of twisting of the torso for the operator 1 because operator 1 no longer has to stand to the right of the workstation. With that being said, operator 1's brief score decreased by a percentage of 24 and operator 2 decreased by 12%.
The proposed workstation has dual benefits. Not only does it lower the brief score, but also reduces the cycle time. Convenience allows the operators to assemble the screens at a faster rate. By rearranging the location of the materials, using a more effective printer, and introducing a label dispenser, workers are able to shave seconds off the cycle time. Calculations for motion time savings indicated a projected reduction of 5.4 seconds. This means that the new cycle time is approximately 11% less than the original. Cumulatively, this amounts to 870 more frames per week.
We believe that our table will have major benefits for both the company and the workers. First off, the whole process is much more convenient, simpler, easier, and it's quicker. The cycle time is shortened and the rate of assembly is much faster. The operators will feel comfortable and safer while doing their job, and the company will experience higher profits.
In further continuing 5S, improvements such as a height adjustable table and a mechanism for installing quarter brackets can be implemented. Because 5S deals with always improving efficiency, there is no ceasing when it comes to continuous improvement.
We'd like to thank Brian Garcia, Wanda Duran, Adam Luthen, and Jose Alvarado from Silverline, as well as our RTAs Ed Hahn and Taylor Au. We'd like to thank our director, Dean Rosen, and our associate director, Dean Antoine, and also our sponsors and Rutgers University for making this whole experience possible. Thank you, and are there any questions?
Could you explain the two-bin system? I didn't quite understand what the advantage was of having two bins instead of one.
So with two-bin system, basically it's used to, okay, let me start. The two-bin system, basically it's comprised of two bins that are basically on an angle, so that once you finish one bin, it's basically you're supposed to pick up the first bin, move it aside, the second bin will slide in, so that you can have ready access to parts. But at the same time, because it's on an angle, the parts inside the bin will also slide forward, so the worker won't have to reach too far back if they need the parts in the bin.
Any other questions?
Can you explain? Have your recommendation been implemented by the company?
The workstation hasn't been fully constructed yet, but I think the company's going to implement it.
Could you clarify the calculation for the payback period of roughly about a month? Is it coming from profit margins or wage reduction or both?
So basically, since we saw how much the cycle time improved, and then based on that, we were able to see how many frames per day, per week, and per year, how many more frames they were able to produce. And then based on the cost of producing a frame, we were able to see over time how long it would take to pay back the workstation. And based on the changes we made, it was about $922. So that would be paid back in about a month.
So you're assuming there's enough demand for these screens or these windows
Yes.
for the company to sell all of them
Yes.
and not producing downtime for workers?
Yes.
Do you envision adding any automation to the 5S process? Like when you mentioned the labels, like do you envision like having a robot do that or something?
Yeah, I mean, the end goal is to really make it as easy as possible for the workers, but this is just the beginning of making it. Any other questions? Thank you.
Thank you.